And now in this lecture we'll answer two questions. In the first question we find out the height of this right triangle ABC. The height edge is equal to AB. And in the second question we find out the area of this square ABCD. And we also have to find out the length of this tangent PQ. So we start with the first question. In the drawing, we have a circle that is inscribed by this right triangle, triangle ABC. This is angle ABC, this is the right angle. You know that the base BC of this right triangle ABC equals to 40 units in its length. You also know that the radius of this circle equals to 4 units in its length. The height BC, the height AB is equals to h is the missing side. So we have to find out the length AB is equals to h. So, first of all, we will define the relevant point to this question with letters. We will define the center of this circle. This point is point O. We will define the point of tendency of tangent AB. With this circle, this point is point D. Likewise, we will define the point of tendency of tangent BC. With this circle, this point is point E. And finally, we will define the point of tendency of tangent AC with this circle. This point is point F. In the next step, we will join points O and E together by a straight line. Point O is the center of this circle, point E is the point of the circle itself, therefore OE is the radius of this circle, is equals to 4 units in its length, according to what's given in the question. The radius OE is equals to 4, the radius OE is drawn to point E, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to rule 1. Likewise, we will join points O and D together by a straight line. OD is of course the radius of this circle, is equals to 4. The radius OD is equals to 4, the radius OD is drawn to point D, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AD is perpendicular to DO, it means that this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to the same rule, rule 1. So inside the small quadrangle DOEB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle. In total, the must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees, and therefore this fourth angle must be equal to 90 degrees inside. So inside the small quadrangle DOEB we have 4 angles, therefore we can relate to quadrangle DOEB is a rectangle. But you also know that the opposite sides of a rectangle are equal to each other, so in the small rectangle DOEB, side DO must be equal to the opposite side BE, but DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the same rule, in the same rectangle, in the same small rectangle, DOEB, side OE must be equal to the opposite side DB. But OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So if you found out that quadrangle ODBE is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other, each side equals to 4 units in its length. What is the length of this missing 970C? From the drawing, it is very easy to see that EC equals to BC minus BE. So now we found out that the missing 970C is equal to BC minus BE. So EC in total equals to BC equals to 40 according to what is given as a question, minus BE equals to 4. So in total EC equals to 40 minus 4, that is 36. EC equals to 36 units in its length. In the next step, we will implement rule 2 in our drawing. So repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So in the drawing, we have a circle. This is the common standpoint, point P. From this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. This is the common standpoint, point C. From this common standpoint, point C, we have two tangents to this circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But CE equals to 36, therefore CF must be also equal to 36 units in its length. In the next step, we implement rule 2. And this common standpoint, point A. For this common standpoint, point A, we have two tangents to this circle, tangent AD and tangent AF. And according to rule 2, they are equal to each other. That is to say, AD equals to AF. AD equals to AF. According to rule 2. So if we define the length of AD as X, then AF must be also equal to X units in its length, according to rule 2. So in the next step, we will implement the quadration of this big right triangle, triangle ABC. Here by PT is the relation for quadration. According to the Pythagorean theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle ABC is AC. The square of the hypotenuse is AC square. It must be equal to AB square plus BC square. And again, in this right triangle ABC, according to the Pythagorean theorem, AC squared, this is the square of the hypotenuse, equals to AB square plus BC square. AC in total equals to X plus 36, therefore AC equals to X plus 36 square. And it is equal to AB square. AB in total equals to X plus 4, therefore AB square is X plus 4 square. Plus BC square. BC equals to 40, therefore BC square is 40 squared, that is 1600. So in total, we actually found out that X plus 36 squared equals to X plus 4 squared plus 1600. Here we will open the brackets on both sides of this equation. And again, that X plus 36 squared equals to X squared plus 36 squared is actually 1296 plus 2 times x times 36, that is 72x. and it is equal to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, it is 16, plus 2 times x times 4 is 8x, plus 1600. So here we have x squared on both sides of this equation, so x squared again cancelled. After you cancel x squared, in this side of the equation you left only 1296 plus 72x equals to 1600 plus 16 is 1616 plus 8x. So total we found out that 1296 plus 72x equals to 1616 plus 8x. Here we will subtract 8x from this equation. So here 8x will get cancelled and we left only with 1616 in this side of the equation, while on the other side of the equation 72x minus 8x is 64x plus 1296. So total we found out that 1296 plus 64x equals to 1616. Here we subtract 1296 from this equation. So here 1296 will get cancelled and we left only with 64x equals to 1616 minus 1296 equals to 320. Here we divide this equation by 64. And we get that x equals to 320 over 64, that is 5. So x equals to 5 units in its name. X equals to 5 units in its name. Our task is to find out the length of AB. AB in total equals to AD plus DB. So AB equals to AD is X plus DB is 4. So AB equals to X plus 4. AB equals to X is 5 plus 4. 5 plus 4 is 9. In total we found out that the height AB that equals to edge is equal to 9 units in its length. And again we found out that the height AB that is equal to edge is equal to 9 units in its length. So finish the answer of the first question. In the next step, I present you the second question of this lecture. And the answer of the second question, that has actually 2 questions. In the second question, our task, we have 2 tasks. The first task is to find out the area of this square ABCD, and the second task is to find out the length of this tangent QP. So in the drawing we have square ABCD. Inside this square ABCD we have this quarter circle and this semicircle. The quarter circle and the semicircle are tangent to each other, or they touch each other at this point. We define their touching point of their point of tendency. This point is point K. So the concentric and the semicircle have an acceleration between them at point K. That is to say, they touch each other accelerate at point K. In addition, we know that the radius of this semicircle is equal to 17 units in its length. So we define the center of this semicircle. This point is point O. Then the radius O equals to 17 units in its length. Likewise, the radius, when you find this point, is point Z. So the radius OZ also equals to 17 units in itself, according to what is given in the question. When you find the short line segment, this short line segment ZB as X. When you find this point is point L. So when you find the short line segment BL as Y, we know that DL is the radius of this quarter circle. That's equal to 36 units in itself, according to what's given us in the question. So the first task is to find out the area of this square ABCD. So what is the area of this square ABCD? We know that the area of any square is equal to the length of one side squared. We choose one side of this square ABCD. We choose AB as the one side of this square ABCD, so it is AB square. The area of square ABCD equals to AB square. AB in total equals to 17 plus 17, that is 34 plus x. So in total AB equals to 34 plus x. Therefore, AB square must be equal to 34 plus x squared. So in total, we found out that the area of square ABCD, according to the first method of calculation, is equal to 34 plus x squared. We choose one side of this square ABCD as BD, therefore the area of the square ABCD will be equal to BD square. According to the second method of calculation, the area of the same square ABCD is equal to the length of one side, that is side BD squared. BD in total equals to y plus 36. Therefore, BD square will be equal to y plus 36 square. And again, BD in total equals to y plus 36. Therefore, BD square must be equal to y plus 36 square. So according to the second method of calculation, the area of the same square ABCD is equal to 36 plus y squared. So we have two different equations for the area of the same square ABCD. According to equation 1, the area of square ABCD is equal to 34 plus x squared, while according to equation 2, the area of the same square ABCD is equal to 36 plus y squared. Therefore, we will create equation 3 that states that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. So the area of square ABCD according to the first method of calculation equals to 34 plus x squared. And it must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to 36 plus y squared. So in total we should find out that 34 plus x squared equals to 36 plus y squared. Here we take a root out of this equation, equation 3, and finding out that according to equation 3, the square cancels the root, or the root cancels the square, and here we left only 34 plus x. Likewise, here the root cancels the square, and we left only here with 36 plus y. So in total we should find out that 34 plus x equals to 36 plus y. Here we subtract 34 from this equation, equation 3, and get that here 34 will get cancelled, and we have only x on this side of the equation, while on the other side of the equation we have 36 minus 34 is 2 plus y. So in total we should find out that according to equation 3, x equals to y plus 2. X equals to y plus 2. In the next step, we'll implement in our drawing rule 10. Because of the fact that the semicircle have an acceleration, if the quarter circle is point K, we can definitely implement here rule 10. Whenever we have an acceleration between two circles or a semicircle, so we can implement rule 10. So a bit quicker on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes through their touching points. So in the drawing, we have those two circles that touch each other externally, this point P. The center of this circle is 0 at point O. The center of this circle is 0 at point M. The straight line that connects the centers together is of course the straight line OM. And according to this rule 10, the straight line OM must pass for their touching point, that is point P. Again, the straight line OM must pass for point P, that is their touching point. Or OPM is one straight line. Again, according to this rule 10, OPM is one straight line. If OPM is one straight line, it means that OM in total must be equal to OP plus PM. So we can implement rule 10 in our drawing. The center of this semicircle is 0 at point O. The center of this quarter circle is 0 at point D. The third line that connects the cells together is of course the third line OD. According to rule 10, the third line OD must pass for point K. For point K, that is the touching point. Again, the third line OD must pass for the touching point, that is point K. OKD is one third line. Again, OKD is one third line. So we join points O and D together by the third line, and according to rule 10, the third line OD must pass for point K, that is the touching point. Indeed, the third line OD passes for point K, that is the touching point, exactly according to rule 10. ABCD is a square, therefore this is a right angle, of course. So in the next step, we'll implement the Pythagoras theorem on this right angle triangle OBD. We'll implement the Pythagoras theorem on this right angle triangle OBD. But before that, what is the left of 4D? Because of the fact that OKD is one side line, it means that OD in total must be equal to OK plus KD. OK is the radius of this semicircle, that is equal to 17, plus KD. KD is the radius of this quarter circle, that is equal to 36. So in total, OD equals to 17 plus 36, that is 33. OD equals to 33 units in its length according to rule 10. So the opposite OD on this right angle again ODB equals to 53 units in its length. We know that DB in total equals to 36 plus Y and OB equals to 17 plus X. So we implement the Pythagoras theorem on this time OBD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. That is to say, OD squared, that is the square of the hypotenuse, must be equal to OB squared plus BD squared. But again, in this right triangle OBD, according to the Pythagoras theorem, the following equation is true. OD squared, that is the square of the hypotenuse, equals to OB squared plus BD squared. OD equals to 53 units in its length, therefore OD squared equals to 53 square. 53 square equals to 2,809. And it is equals to OB square. OB is 17 plus X, therefore OB square is 17 plus X square. Plus BD square. BD in total equals to 36 plus Y, therefore BD square equals to 36 plus Y square. So in total we found out that 2,809 equals to 17 plus X square plus 36 plus Y square. So 2,809 equals to 17 plus X square. 17 plus X square equals to 17 square This is 289 plus x squared plus 2 times x times 17. This is actually 34x plus bd squared. This is actually 36 plus y squared. 36 plus y squared equals to 36 squared this is 1296 plus y squared plus 236 times y, that is 72y. But before that, we only found out that x equals to y plus 2. Therefore, we can substitute in this equation x by y plus 2. So, if x equals to y plus 2, this expression equals to 17 plus 2, that is 19 plus y. So this expression in total equals to 19 plus y squared. So today we shall know that 2809 equals to 17 plus x squared equals to 19 plus y squared. We just substitute x by y plus 2. We got that 17 plus x squared equals to 19 plus y squared plus 36 plus y squared. So today we found out that 2809 equals to 19 plus y squared plus 36 plus y squared. Here we open the brackets on this side of this equation and get that 2809 equals to 19 plus y squared. 19 plus y squared equals to 19 squared, that is actually 361 plus y squared plus 2 times 19 times y, that is 38y plus 36 plus y squared. 36 plus y squared equals to 36 squared. This is actually equal to 1296 plus y squared plus 2 times y times 36, that is 72y. So in this side of the equation we have 2809, and on the other side of the equation we have y squared plus y squared is 2y squared, and we have also 361 plus 1296 is equal to 1657, and we have also 38y plus 72y equals to 110y. So in total we found out that 2809 equals to 2y squared plus 1657 plus 110y. Here we'll subtract 2809 from this equation. So in this side of the equation we are left with nothing, that is to say 0. And on the other side of the equation we have 2y squared plus 110y And 1657 minus 2809 equals to minus 1152. So in total, we should find out that 0 equals to 2y squared plus 110y minus 1152. Here we divide this equation by 2 and get that y squared over 2 is y, 2y squared over 2 is y squared. We have 110y over 2 is 55y minus 1152 over 2 is minus 576 equals to 0 over 2 is 0. So in total we found out that y squared plus 55y minus 576 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. In this general formula for a quadratic equation, a, b, and c are the coefficients of this quadratic equation. And x is the variable that we are looking for. We'll find out the value of x according to this the following general formula. Actually, x equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. The variable that we are looking for is y, so x equals to y. The coefficient a equals to 1, the coefficient b equals to 55, and finally the coefficient c equals to minus 576. So actually we have all the data that is needed in order to find out the variable that we are looking for in our specific quadratic equation, that is y. The only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x. In this way we find out the value of the values of y, because y might have two solutions. So we'll do it now and get that x equals to y, so we substitute x in this general formula by y. Y is the variable that we are looking for. And is equals to minus b. B is 55, therefore minus b is minus 55, plus minus square root of b squared. B is 55, therefore b squared is 55 squared. 55 squared equals to 3025. Minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. So c is minus 5076, so minus 4 times minus 5076 is equal to 2304. Divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we should now know that y, that is the variable that we're looking for in our specific quadratic equation, equals to minus 55 plus minus. Inside the root we have 3025 plus 2304. In total is equal to 5329. Divided by 2. So in total we actually found out that y equals to minus 55 plus minus the square root of 5329 is equal to 73 over 2. So in total I should found out that y equals to minus 55 plus minus 73 over 2. So here we have two solutions that are possible for y. We choose only the positive solution for y, because y is the length of this short line must be q, therefore as a length it must be a positive number. So the positive solution for this equation is as follows. Y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18. 18 over 2 is 9. So in total we found out that y equals to 9 units in its length. And we already found out that x equals to y plus 2. So x equals to y plus 2, x equals to y is 9 plus 2. 9 plus 2 is 11. So in total we found out that x equals to 11 units in its length and y equals to 9 units in its length. Our first mission is to find out the area of this square ABCD. That is our first task. Note that the area of any square equals to the length of one side squared. So it is AB squared. AB in total equals to 34 plus x. Therefore AB squared equals to 34 plus x squared. AB equals to 34 plus x. Therefore AB squared equals to 34 plus x squared. But x is 11, so this expression equals to 34 plus 11 squared. 34 plus 11 is 45, so it is 45 squared. 45 squared equals to 2025. So in total we found out that the area of square ABCD, this is the area that we are looking for in this question, is equal to 2025 square units in size. Repeat again. We actually found out that the area of this square ABCD is equal to 2025 square units in size. So we finish with the first test. The second test is to find out the length of this tangent QP. So what is the length of tangent QP? So first of all, in order to find out the length of this tangent PQ, we define this missing angle BDO as alpha. And we focus on this green triangle BOD. This green triangle BOD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this spread missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, this spread missing angle must be equal to 90 degrees minus alpha. This is tangent PQ that is tangent to this quarter circle at point K. dk is the radius of this quarter circle. The radius dk is equals to 36. The radius dk is drawn to point K, that is the point of tendency of tangent PQ with this quarter circle. Whenever we have a radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to rule 1. So inside this small right green triangle DKQ, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. According to the sum that said that the sum of the angles in the triangle is equal to 180 degrees. 90 degrees minus alpha, 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we will do a construction, that is to say, from this point P, we will do perpendicular on BD again. From this point P, we will do perpendicular on BD. So here, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We will define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we get the small quadrilateral PTDC. Inside this small quadrilateral, those two angles are both right angles. Why? Because the two angles inside the big square ABCD. Therefore, you know that the angles of inside any square are right angles. So those two angles, they are both right angles. CD is one side of square ABCD. All the sides of any square are equal to each other. So CD must be equal to 34 plus x. X is 11, so 34 plus 11 is 45. CD equals to 45 units in its length. So inside the small quadrilateral PTCD, we have 1, 2, 3 right angles. This is a right angle according to our construction. The sum of right angles is 270 degrees, so 270 degrees plus the size of this fourth angle in total must be equal to 360 degrees. According to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth angle must be equal to 90 degrees in size. So inside the small quadrilateral we have 4 right angles, therefore can relate to quadrilateral PTDC as a right angle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle PDDC, side CD must be equal to the opposite side PT, but CD is 45, therefore PT must be also equal to 45 units in its length. So inside this right triangle PQT, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees according to our construction. Therefore, this spread missing angle must be equal to alpha. according to the sum rule, that the sum of the angles in any triangle is equal to 180 degrees. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, this third missing angle must be equal to alpha. So in the next step, we will prove that the right triangle PQT can go into this ring right triangle DOBD according to angle side angle rule. According to angle side angle rule. So write it down. So we have to prove this is the right ring triangle OBD. That this right triangle OBD can run to this right triangle QPT. So write again right triangle OBD can run to this right triangle QPT. First of all, those two angles are both equal to alpha and therefore they are equal to each other. So actually, this is the angle BDO in the great triangle BOD. And it is equal to this angle, the actual angle QPT in the right triangle QPT. Then again, angle BDO in the right triangle OBD equals to angle OPT in the right triangle QPT. They are both equal to alpha and therefore they are equal to each other. This is actually angle QPT. And again, angle BDO in the right triangle equals to angle QPT in the right triangle QPT. They are both equal to alpha and therefore they are equal to each other. BD is one side of square ABCD, therefore it is equal to 45 units in its length. All the sides of any square are equal to each other. BD equals to 45. And therefore, side BD of this green right triangle OBD equals to side PT of this right triangle QPT. Because PT also equals to 45 units in its length. So BD equals to PT. And again, we found out that side BD of the green right triangle OBD equals to side PT of the right triangle QPT. They are both equal to 45 and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So actually this is again OBD. And again right triangle OBD, and it is equal to this angle, this is actually angle QPT. In the right triangle QPT. And again, we should find out that angle OBD, again, right triangle OBD equals to angle QPT. In the right triangle QPT, they are both equal to 90 degrees and therefore they are equal to each other. So in total, we should find out that again, right triangle OBD can go into this right triangle QPT according to angle side angle rule. So write it down. Again, right triangle OBD can point, this is the sign of can point, to the right triangle QPT according to angle side angle rule. What is angle side angle rule? Angle side angle rule says that those two angles in the side that is included between those two angles, that is actually side BD, and on this angle OBD are corresponding equal to those two angles, and the side that is included between those two angles, that is side PT, of this triangle QPT. Therefore, those two triangles can go into each other according to angle side angle rule. Again, we have those two angles. The side that is included between those two angles in this triangle corresponding equal to those two angles, and the side that is included between those two angles in this triangle QPT. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will derive that their corresponding sides must be also equal to each other and their lengths. The hypotenuse OD of this right triangle is the corresponding side of the hypotenuse QP of this right triangle QPT. Therefore, OD in the green triangle equals to the corresponding side of this right triangle QPT, that is actually the hypotenuse QP. So we should find out that OD equals to QP. Again, OD equals to QP according to the rule that says that corresponding sides and congruent triangles are equal to each other. The green triangle OBD can go into this triangle QPT, therefore the corresponding sides must be also equal to each other in their lengths. That is to say, the hypotenuse of this green triangle OBD is OD must be equal to the hypotenuse of this triangle QPT, that is actually QP. The two hypotenuses are the corresponding sides of these two right triangles. So OD equals to QP, but we already found out that OD equals to 53. So we can write here that OD equals to 53. And for this equation 53 equals to OD equals to QP, we derive that QP also equals to 53 units in its length. Again, we found out that the length of the hypotenuse QP is equal to 53 units, and the area of this square ABCD is equal to 2025 square units in its size. So we finished to answer the second question. In the next step, I'll solve the next one. That is to say, repeat on the solution of the first question, and then repeat on the solution of this second question. The first question, our task is to find out the height AB of this right triangle ABC. So in the drawing we have the right triangle ABC. This is a right angle. BC equals to 40 units in its length. This circle is described by this right triangle ABC. The radius of this circle is 4. Again, our task is to find out the height AB of this right triangle ABC. So first of all, we define the relevant points to this question with letters. We define the center of this circle, this point as point O. We define the point of tendency of tangent AC with this circle, this point as point F. Likewise, we define the point of tendency of tangent AB with this circle, this point as point D. And finally, we define the point of tendency of tangent BC with this circle, this point as point E. In the next step, we join points O and E together by straight line. Point O is the center of this circle, point E is the point of the circle itself, therefore OE is the radius of this circle. This equals to 4 units in itself, according to what is answered the question. the radius OE is equals to 4. The radius OE is drawn to point E, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to all 1. Likewise, we join points O and D together by side line. O is, of course, the radius of this angle, that is equal to 4. The radius OD is equals to 4. The radius OD is drawn to point D, that is the point of tendency of tangent AB with this angle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule, rule 1. So inside the small quadrangle DOEB, we have 1, 2, 3 arteries. The sum of 3 arteries is 270 degrees, so 270 degrees plus the size of this 4 pieces angle, the total must be equal to 360 degrees, according to the rule that said that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this 4 pieces angle must be equal to 90 degrees in size. So inside the small quadrangle DOEB, we have 4 arteries, therefore can relate to quadrangle DOEB as a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle DOEB, side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must be also equal to 4 units in itself. Likewise, according to the sum rule, in the same small rectangle OEBD, side OE must be equal to the opposite side DB. But OE is 4, therefore DB must be also equal to 4 units in itself. So in total, we found out that the small quadrangle DOEB is not a rectangle but a square, because of the fact that all 3 sides are equal to each other. All 3 sides are equal to each other. Each side equals to 4. What is the length of this piece in line 7 to line 7 EC or tangent EC? EC in total equals to BC minus BE. EC equals to BC minus BE. So EC in total equals to BC, this is 40 according to what is given in the equation, minus BE, this is 4. So in total, EC equals to 40 minus 4, that is 36. EC equals to 36 units in itself. The next step, we implemented rule 2 in our drawing. So I'll pick quickly on rule 2. According to rule 2, the lengths of 2 tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint, point P. From this common standpoint, point P, we have 2 tangents to this circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. We can actually implement rule 2 in our drawing. We focus on this common standpoint, point C. From this common standpoint, point P, we have 2 tangents to this circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But CE is 36, therefore CF must be also equal to 36 units in itself. And likewise, from this common standpoint, point A, we have 2 tangents to this circle, tangent AD and tangent AF. And according to rule 2, they are equal to each other. That is to say, AD equals to AF. So if we define the length for AD as x, then AF must be also equal to x. According to rule 2. So the next step, we implemented the Pythagoras theorem on this big right triangle, triangle ABC. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in this right triangle ABC, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. Repeat again, this right triangle ABC, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. The hypotenuse AC equals to x plus 36, therefore AC squared is x plus 36 squared. And it equals to AB squared. AB in total is x plus 4, therefore AB squared is x plus 4 squared, plus BC squared. BC is 40, therefore BC squared is 40 squared, that is 1600. So in total, we found out that x plus 36 squared equals to x plus 4 squared plus 1600. Here we open the brackets on both sides of this equation, and we found out actually that x plus 36 squared equals to x squared plus 36 squared. 36 squared equals to 1296 plus 2 times x times 36, that is 72x, equals to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x plus 1600. Here we have x from both sides of this equation, so x squared is cancelled. After getting x squared, in this side of the equation we left only with 1296 plus 72x, while on the other side of the equation we left only with 16 plus 1600 is 1616 plus 8x. So in total we found out that 1296 plus 72x equals to 1616 plus 8x. So here we subtracted 8x from this equation, so here 8x we can cancel, we left only with 1616, while on the other side of the equation we have 72x minus 8x is 64x plus 1296. So in total we found out that 1296 plus 64x equals to 1616. Here we subtracted 1296 from this equation, so here 1296 will get cancelled, and we left only with 64x. While on the other side of the equation, 1616 minus 1296 equals to 320. So in total, we found out that 64x equals to 320. Here we divided this equation by 64. And we found out that x equals to 320 over 64, that is 5. So x equals to 5 units in its length. Our task is to find out the height of this right triangle ABC, that is AB. AB in total equals to AD plus DB. AB equals to AD plus BD. So AB equals to AD. AD is x plus DB, that is 4. Again, AD is x, DB is 4. So in total, AB equals to x plus 4. X is 5. Found out that x equals to 5. So AB equals to x, that is 5 plus 4. 5 plus 4 is 9. So in total, we found out the length of AB, right, AB edge, equals to 9 units in its length. AB equals to 9 units in its length. So we finished to repeat on the solution of the first question. In the next step, I repeat on the solution of the second question. In the second question, we have to find out, our task is to find out the area of this square ABCD, and also have to find out the length of this tangent QP. So in the drawing, we have a semicircle and a quarter circle that are both located inside this square ABCD. This is tangent QP, that is tangent to both circles at this point. When you find the touching point, this point is point K. So first of all, we have to find out the area of this square ABCD. So in the first step, we define the relevant points to this question with letters. We find the center of this semicircle. This point is point O. We define this point as point Z. We define this short line ZB as X. We define this point as point L. So we define the length of this short line BL as Y. DL is the radius of this quarter circle. That is equals to 36 units in its length, according to what is given in the question. So, what is the area of this square ABCD? Actually, we know that the area of any square equals to the length of one side of the square squared. So we choose AB as the length of one side. Therefore, the area of this square ABCD must be equal to AB squared. The area of square ABCD must be equal to the length of one side, that is AB squared. AB in total equals to 17 plus 17, that is 44 plus x. AB equals to 34 plus x, therefore AB squared must be equal to 34 plus x squared. Again, AB equals to 34 plus x, therefore AB squared must be equal to 34 plus x squared. So in total, we found out that according to the first method of calculation, the area of square ABCD is equal to 34 plus x squared. The next step, we choose the length of this square ABCD as BC and BD. Therefore, the area of this square ABCD must be equal to BD squared. So according to the second method of calculation, the area of the same square ABCD must be equal to the length of one side, that is BD squared. BD in total equals to y plus 36, therefore BD squared must be equal to y plus 36 squared. BD square must be equal to y plus 36 square. So according to the second method of calculation, the area of the same square ABCD must be equal to 36 plus y square. According to equation 1, the area of the same square ABCD equals to 34 plus x square. So we have two different equations for the area of the same square ABCD. Therefore, we get the equation 3 that says that the area of square ABCD according to the first method of calculation must be equal to the area of the same square ABCD according to the second method of calculation. Very simple equation. The area of square ABCD according to the first method of calculation equals to 34 plus x squared. It must be equal to the area of the same square ABCD according to the second method of calculation. This equals to 36 plus y squared. So in total we found out that according to equation 3, 34 plus x squared equals to 36 plus y squared. Here we took out of this equation. So here the root cancels the square, and you left only with 34 plus x, while on the other side of the equation, the root also cancels the square, and you left only with 36 plus y. So in total, according to equation 3, we actually found out that 34 plus x equals to 36 plus y. If we subtract the 34 from this equation, and finally found out that here 34 will get cancelled, and left only with x, while on the other side of the equation, 36 minus 34 is 2. So in total, we have here 2 plus y. So x equals to 2 plus y, or x equals to y plus 2. In the next step, we implemented rule 10 in our drawing. The semicircle touches the quarter circle at this point K, therefore we can implement here rule 10. They touch each other externally at this point K. So please click on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching points. In the drawing, we have those two circles that touch each other externally at this point P. The center of this circle is 8.0. The center of this circle is 8.m. The straight line that connects the circles together is, of course, the straight line OM. And according to this rule 10, the straight line OM must pass through their touching point at this point P. Again, the straight line OM must pass through point P, that is their touching point. OPM is what's the line. Again, OPM is what's the line. If OPM is what's the line, it means that OM in total must be equal to OP plus PM. So we can implement rule 10 in our drawing. Because in our drawing, we have an external line between the semicircle and the quarter circle at point K. That is to say, they touch each other externally at point K. Therefore, we can implement here rule 10. The center of this semicircle is at point O. The center of this quarter circle is at point D. The straight line that connects the centers together is, of course, the straight line OD. According to rule 10, the straight line OD must pass through their touching point, that is point K. Again, the straight line OD must pass through point K, that is their touching point. OKD is one straight line. OKD is one straight line according to rule 10. If OKD is one straight line, it means that OD in total must be equal to OK, that is the radius of this semicircle, that is 17. Plus KD, that is the radius of this quarter circle, that is 36. So in total, OD must be equal to 17 plus 36, that is 53. So OD equals to 53 units in its length. The next step, we implemented Pythagoras theorem on this given right triangle triangle OBD. According to the Pythagoras theorem, in a right triangle, the square of the opponents equals to the sum of the squares of the perpendiculars. That is to say, OD squared, that is the square of the opponents, must be equal to OB squared plus BD squared. And again, according to the Pythagoras theorem, this green right triangle OBD, the following equation is true. OD squared, that is the square of the opponents, must be equal to OB squared plus BD squared. OD is 53, therefore OD squared is 53 squared. 53 squared equals to 12,809. Plus OB squared. OB is 17 plus x, therefore OB squared is 17 plus x squared plus BD squared. BD in total is 36 plus y, therefore BD squared is 36 plus y squared. So in total we found out that 2,809 equals to 17 plus x squared plus 36 plus y squared. We only found out that x equals to y plus 2. Therefore, we can substitute x in this equation by y plus 2. So we get that 17 plus x equals to y plus 2. So total this expression equals to 17 plus 2, that is 9 plus y. So total this expression equals to 19 plus y squared. So 2809 equals to 17 plus x squared is 19 plus y squared plus 36 plus y squared. So in total we found out that 2809 equals to 19 plus y squared plus 36 plus y squared. Here we open the brackets on this side of this equation and found out that 2809 equals to 19 plus y squared. 19 plus y squared equals to 19 squared, that is 361 plus y squared plus 2 times 19 times y, that is 38y plus 30x plus 36 plus y squared. 36 plus y squared equals to 36 squared, that is 1296 plus y squared plus 2 times 36 times y, that is 72y. So in this side of the equation we have 2809 equals to y squared plus y squared is 2y squared. We also have 8y plus 38y plus 72y is under 10y, and we also 361 plus 1296 equals to 1657. So in total we found out that 2809 equals to 2y squared plus 1657 plus 11 plus under 10y. So here we subtracted 2809 from this equation. So in this side of the equation we have nothing, that is to say 0, and on the other side of the equation we have 2y squared plus under 10y, and 1657 minus 2809 equals to minus 1152. So in total we found out that 0 equals to 2y squared plus 110y minus 1152. Here we divided this equation by 2, and found out that 2y squared over 2 is y squared, and 110y over 2 is 55y, minus 1152 over 2 is minus 576 equals to 0 over 2 is 0. So in total we found out that y squared plus 55y minus 576 equals to 0. So this is the quadratic equation. Repeat again. This is the quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say y squared plus 55y minus 576 equals to 0. The variable that we are looking for is y. So here x equals to y. The coefficient a equals to 1, the coefficient b equals to 55, and the coefficient c equals to minus 576. So we should have all the data that is needed in order to find out the value of y. Just have to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of y, because y might have two solutions. So we did it when we found out that again x equals to y, so we substitute x by y, this general formula, and it equals to minus b. B is 55, therefore minus b is minus 55, plus minus square root of b squared. B is 55, therefore b squared is 55 squared. 55 squared equals to 3025. Minus 4 times a times c. So it is minus 4 times a is 1. So minus 4 times 1 is minus 4 times c. C is minus 576. So minus 4 times minus 576 equals to 2304. So in total inside the root we have 3025 plus 2304 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we found out that y equals to minus 55 plus minus 3025 plus 2304 equals to 5329 divided by 2. So y equals to minus 55 plus minus the square root of 5329 is 73 divided by 2. So in total we found out that y equals to 155 plus 173 over 2. So here we have two solutions that are possible for y. We take into account only the positive solution for y, but because of the fact that y is a length, and as a length it must be a positive number. The positive solution for y is as follows. Y equals to 155 plus 73 over 2. 155 plus 73 is 18, 18 over 2 is 9. So in total, if you found out y equals to 9 units in its name. We already found out that x equals to y plus 2. So x equals to y, that is 9 plus 2. 9 plus 2 is 11. So in total, we found out that x equals to 11 and y equals to 9. Our first test is to find out this first square ABCD. What is the area of this square ABCD? Actually, we know that the area of any square equals to the length of one side squared. Choose one side of this square ABCD, SAB. So the area of square ABCD must be equal to AB squared. AB in total equals to 34 plus x, therefore AB squared must be equal to 34 plus x squared. So AB squared equals to 34 plus x squared. X is 11, so 34 plus x is 34 plus 11 squared. 34 plus 11 is 45. So it is 45 squared. 45 squared is 2025. So in total, we found out that the area of square ABCD equals to 2025 square units in its size. So again, the area of this square ABCD, that is the area that we're looking for, is equal to 2025 square units in its size. The next step, we found out the length of this tangent QP. What is the length of tangent QP? So, first of all, this is the right triangle OBD, the right triangle OBD. We define this angle as alpha, so in the right triangle OBD, this is the right angle, this angle equals to 90 degrees in its side, this angle equals to alpha, therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. This is tangent QP, that is tangent to this quarter circle at point K. The radius dk is equal to 36. The radius dk is drawn to point K, that is the point of tendency of tangent PQ with this circle, with this quarter circle. You have a radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius KD. If PQ is perpendicular to KD, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to all 1. So in this green small triangle QKD, this angle equals to alpha, this angle equals to 90 degrees, therefore this front angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, this is the sum of the angles in a triangle. In the next step, we did the construction, that is to say, from point P, we do perpendicular on BD. Again, from point P, we do perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and BD, this point is point T. By doing this construction, we get the small quadrilateral PT DC. Inside the small quadrilateral PT DC, those two angles are both angles because there are two angles of square ABCD. Therefore, they are both right angles. This is a right angle according to our construction. So in total, in the small quadrilateral PTDC, we have 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle, in total must be equal to 360 degrees, according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth angle must be equal to 90 degrees in size. So inside the small quadrilateral PTDC, we have 4 angles, therefore can relate to the quadrilateral PTDC as a rectangle. CD is one side of square ABCD. CD in total equals to 34 plus x. X is 11, so 34 plus x is 34 plus 11, that is 45. AB equals to 45, therefore CD must be also equal to 45 because ABCD is a square. So CD equals to 45. So in the small rectangle PTDC, the opposite sides are equal to each other. That is to say, CD equals to the opposite side PD. But CD is 45, therefore the opposite side PD must be also equal to 45 units in its length. So inside this right triangle QPT, this angle equals to 90 degrees. According to our construction, this angle equals to 90 degrees minus alpha, and therefore this this angle must be equal to alpha. Well, because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in a triangle. In the next step, we prove that the green right triangle DOBD can go into this right triangle QPT according to against side angle rule. So why the green right triangle OBD can go into this right triangle QPT. First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, BD equals to PT, they are both equal to 45 units, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So in total, we found out that the green right triangle OBD can go into this right triangle QPT according to against side angle rule. And again, in total, we found out that the green right triangle OBD can go into, this is the same congruent to the right triangle QPT according to against side angle rule. What is against side angle rule? We found out that those two angles and the side that is included between those two angles in this green right triangle OBD corresponding equal to those two angles, and the side that is included between those two angles in this right triangle QPT, and therefore those two right triangles can go into each other according to angle side angle rule. Again, we have those two angles, and the side that is included between those two angles in this rectangle corresponding equal to those two angles, and the side that is included between those two angles in this right triangle QPT, and therefore those two right triangles can go into each other according to angle side angle rule. Yeah. In right triangle OBD can go into right triangle QPT according to against side angle rule. And from the fact that the again right triangle OBD can go into this right triangle QPT, we will derive that their corresponding sides must be also equal to each other in their lengths. According to the rule that corresponding sides and congruent triangles are equal to each other. Those two right triangles can go into each other, and therefore their corresponding sides must be also equal to each other in their lengths. The hypotenuse of this green triangle OBD is OD, and it must be equal to the hypotenuse of this right triangle QPT, this is QP. So it is very clear that the hypotenuse of those two right triangles are the corresponding sides. So the hypotenuse of the green triangle OD must be equal to the hypotenuse of the right triangle QPT. Because of the fact there are the two corresponding sides. So OD equals to QP. But we already found out that OD equals to 53. So we can write here that OD equals to 53, and from this equation 53 equals to OD equals to QP, we derive that QP must be also equal to 53 units in its length. So in total, we actually found out that QP, tangent QP equals to 53 units in its length, and there of this square ABCD is equal to 2025 square units in its size. Okay, thank you very much.